Now, as we mentioned in the notes, we're going to ask ourselves what happens when the graph from the left-hand side comes from a much different height than the one from the right-hand side. Well, what we do, just like we do when there was no hole, we put in a vertical line at x equals a. And what we're going to do for this one, this is called the right-handed limit, because what you're doing is you're using the fingers of your right hand. You're walking along the graph and you're just asking yourself, how high would I be when I smashed into the wall? That height, the height of my right hand as it smashes into the wall, we call the right-handed limit. The left-handed limit is very similar, right? You're walking the fingers of your left hand along the graph very fast, and we just want to know how high are the fingers of my left hand when they smash into the wall. We call that the left-handed limit. So very often we can just read this from graphs. Very hard sometimes to actually show those algebraically. We'll worry about that later. Now, if the height of the right-handed limit, which is how high my right hand is coming as it smashes into the wall, is equal to the left-handed limit, which is how high the fingers of my left hand are as they smash into the wall. Well, if those heights are equal, they smash into each other, and we know we call that the limit. If the height of my right hand as it smashes into the wall is not the same as the height of my left hand as it smashes into the wall, we say the limit doesn't exist. Now, there can be a right hand height, there can be a left hand height, but if they're different, that's exactly what we mean when we say the limit doesn't exist.